I'm going to go ahead and record today's session just because my other session I accidentally over-recorded. All right, so for problem number 1, the right triangle on the right is a scaled copy. So this one is the scaled copy. Remember when we say that something is a scaled copy? That's another way of saying it's the new version. So inside of here, I'm going to go ahead and write that this is the new. That means that the other one is considered to be the old. Now, the only problem that I have with this is that the triangle on the left is not facing the same direction as the triangle on the right. So whenever they're not facing the same, we call it orientation, it's not facing the same direction, we like to go ahead and redraw one of them so that way it is facing the same direction. It's easier for you to see which stuff aligns with what. So I'm going to go ahead and just redraw this one, the smaller one. I want to redraw it so that it's facing the same direction as this bigger triangle. So that means it's going to have that L shaped, and then it's going to connect. And then I can just go ahead and properly label that this was the 9 and this was the 9. Now, it does rotate. So sometimes, like let's say that this was a 6, then that 6 now would be located here where my finger is. These are the measurements that line up with each other. You want to make sure you understand that when you are rotating a figure, if I'm rotating it, this is what it looks like. Okay? It's really important, especially if the dimensions are different from each other, that you have them properly labeled. Okay, now when we're going through it, you also want to keep in mind that the question is saying that they want their scale factor in fraction form, and it has to be in simplest form. So when I'm identifying my scale factor, remember that scale factor is found by taking whatever your new values were and dividing them by the old values, or setting it up as a fraction, new over old. So in this situation, my new value was a 33, so that's going to get located on the top of my fraction. My old value was a 9. That's going to get located on the bottom of my fraction. Notice that I chose the same side measurement to focus on. I did not choose a height on one of them and a base on the other. If I choose the height for one, I have to choose the height for the other. And if I choose the base, I have to choose a base. Make sure you understand that. Again, if the measurements are different, it's very important. And then I simplify. Well, 33 over 9 cannot be simplified. That's as simplified as it's going to get. So there's my final answer. No, that can be simplified. They're both divisible by 3. Woo, sorry. They're both divisible by 3. This is going to come out to 11 over 3. Okay? Any questions so far? All right, let's take a look at the next one for problem number 2. So again, problem number 2, are they facing the same direction? Yes. These are both facing the exact same direction. I don't need to do a redraw. This is my scaled copy, so this one's my new, and this one is my old. And I just want to identify what the scale factor is going to be. So again, scale factor is found by taking whatever my new measurement is and dividing it by my old measurement. So in this case, my new measurement is an 18. I chose a base, so I need to choose the base on my old, which was the 12. And then I simplify. 18 over 12, they're both divisible by 6. That's going to give me 3 over 2. And there's my scale factor. Take a moment to get that copy down, then we'll go on to problem 3. Again, we're just going to write down these practice problems. You will then show me that you understand how to do it when you get into the assignment. Pause for a second. All right, so for problem 3, again, they are both squares. They are both squares. This is our new shape. This is our old shape. For our scale factor, we're just going to set it up as new over old. Our new value was 29, and then our old value happens to be the 6. Now 29 over 6 cannot be simplified, so that's as simplified as it's going to get, 29 over 6. Any questions about how to identify the scale factor when given your two shapes? Again, sometimes the shapes are not going to be in the same orientation. They're not going to face the same direction. So you want to make sure that you understand how to work a problem out like that. In fact, I want you to go ahead and turn your paper over to the back. There's a blank space. And we're going to draw a new problem real quickly. We're going to label it problem number 8. I'm going to have a small and a large rectangle. We're going to label this one 3, and this measurement down here is going to be 7. This measurement is going to be 15, and this measurement is going to be 35. I want to find the scale factor here. So the first thing that I need to do is rotate one of my drawings. Does it matter which one I rotate? No. I'm just going to go ahead and rotate this old one. This was my old. I'm going to rotate it so that way they are facing the same direction. The top measurement is now what? What is the top measurement? 3. Okay, this, when I rotate it, the 3 now becomes the top. The 7 now becomes the side. Does everybody understand how that rotation works? Okay, and then our old or our new just stays the same. Then we just pick one of the measurements. So if I pick, let's say I pick 15 as my new, what measurement do I have to pick from my old? If I pick 15, which one of these do I have to pick from the old? 3. I have to pick the 3 from the old. So I'm going to do 15 over 3. 15 over 3 simplifies to a 5. There's my scale factor. Everybody clear about that?
Yes.
You must make sure that you rotate your picture or one of them so that they are facing the same direction, and don't forget to properly label. All right, let's go ahead and flip it back over to the front. We're going to go over problems 4 and 5. So for the second section that you're going to go over in your Delta Math, some of them are going to be just simple proportion problems. Others are going to involve proportions and then solving. And then others are going to have it where you're just multiplying and finding a perimeter or an area. So for here, problem 4, we have city X and city Y. We know that the scale is 1/4 inch is equal to 14 miles. This is my scale factor. My scale factor is 14 miles over 1/4 inch. 14 miles over 1/4 of an inch. Now I want to know how many miles is it if my map shows 3 inches. If my map is showing 3 inches, so this is what we consider the old, just like this was considered the old and this was considered the new. So where am I going to put 3 inches when I create a new fraction? Is 3 inches going to go on top or on the bottom, Hayden? On the bottom, because it was an old and it was inches. 3 inches is going to go on the bottom. I don't know how far apart they really are, so when I don't know a piece of information, what do we always put, guys? If something's missing and unknown, what do we put? Not a 0. A variable, not a question mark. We don't do question marks anymore. We're not in elementary school. We do variables. It is X. It is an unknown amount of miles, so we have X miles. That's considered to be our new. Okay, this should look very familiar to you. We did this a lot last semester. I told you guys we were going to be doing it again this semester. It is a proportion that you need to solve using cross products. So we're going to do 1/4 times x, which gives us 1/4 x. We're going to do 14 times 3, and 14 times 3 gives us 42. And then our last step is to divide. We'll divide both sides by 1/4, and we'll get our distance, our actual distance. So x is going to represent 168 miles. And that's all the question was wanting. They wanted to know the actual distance between the two cities. So all I had to do in this situation was solve for x. They're not all going to be like that. Some of them go a little bit further. So problem 5. Problem 5 is one of those questions that goes a little bit further. So here it says a rectangular floor of a classroom is 38 feet in length and 22 feet in width. 38 feet in length and 22 feet in width. This is considered to be our new. This is what we have. So we have 38 for our length, and we have 22 for our width. I have a scale drawing. That's my old, that has a length of 19 inches. Where is the length going to go? On the top or the bottom? The length. Is it going to go on top or bottom? Top. Length is going to go on top because I put length on top for the other one. We're going to put 19 for my length. I do not know my width. My width is unknown, so I'm going to put x for my width. And then I'm going to do a cross product. We've got 38 times x, which gives us 38x. We then have 22 times 19, which is going to give us 418. We'll then divide both sides by 38. And that's going to give us our width. X is going to equal 11 for my width. Is that what the question was asking for? What is the question asking for? What is the area? The question is asking for the area. What is the area of the scale drawing? So we just now found the length and the width of our scale drawing. If I redraw this, I have a length that is 19 and I have a width that is 11. How do I find area of a rectangle? Multiply, right? We multiply our base and our height, or our length and our width. So write that down. For area, you're going to do your length times your width. You must do your length times your width. We know our length was 19. We know our width was 11. So that makes our area 209, and that's inches squared. That's what I mean when I say it's not all going to be just find what's missing. Some of the questions are going to say find the area, find the perimeter. You have to know the difference between area and perimeter. Okay, when you're ready, go ahead and flip it. Anybody need this still? Once, twice. All right. Okay, when we're taking a look here, a scale drawing of a rectangle park has a scale of 1 centimeter equals 70 meters. 1 centimeter equals 70 meters. They're giving me the dimensions of my old, and I need to figure out what my new is. Remember, we talked about this before, that if you take your old and you multiply it by your scale factor, it's going to equal your new. And I know my scale factor already. 1 centimeter equals 70 meters. That means my scale factor is 70 over 1. What's 70 over 1? 70, right? 70 over 1 is just 70. There's my scale factor. I'm going to take all of these old dimensions, this 8.4 and this 7.3, and I'm going to multiply them by 70. I'm going to multiply them by my scale factor. I'm going to take 8.4 and multiply it by 70. I'm going to take 7.3 and multiply it by 70. When I do so, that's going to give me the dimensions for my new rectangle. That would be 588, and this one's going to come out to 511. That's the dimensions for my new rectangle. 588, 511, and that's 588 meters and 511 meters. Am I done? Is that what the question wanted to know? No, what did the question want to know? Read the question. What does it say? What is the actual perimeter? I need to find the perimeter. Guys, how do we find perimeter of any shape? Elena? Add all sides. I have to add all the sides together. So that means I have to add 588 plus 511 plus, I need to do 588 again because this right side is 588. Plus I have to do 511 again because the top of my rectangle is 511. So once I add all of those together, I'm going to get a perimeter of 2,198 meters. You need to make sure you're paying close attention to what the question is asking. Okay, I want you guys to try number 7 on your own. Make sure that you follow the directions of what we did up here, but read the question carefully to what it's asking. Does it want perimeter? Does it want area? Does it want just the new dimensions? What is it asking of you? All right, let's go over this one. For here, our scale drawing, it has a scale of 1 centimeter equals 120 meters. That represents our scale factor. So our scale factor is 120 over 1, which simplifies to 120. That's the scale factor. Now remember, we're going to take that scale factor and we're going to multiply it by both of the old dimensions. These were our old values. We want to create new values. So we're going to take 8.2 and we're going to multiply it by 120. We're going to take 3.3 and we're going to multiply it by 120. When we do 8.2 times 120, that's going to come out to 984. When we do 3.3 times 120, that's going to come out to 396. Then we got to look at what the area or the question is asking us. The question wants to know the area. So remember, area we said is going to be length times width. Area equals length times our width. So if we know our new dimensions are 984 by 396, then we're just going to multiply those dimensions together. 984 times 396, you guys should have an area of 389,664, and that's going to be meters squared. Okay, you have to make sure that you're taking your time to read each of the questions carefully. What you're going to do right now, you're not going to log into Google Classroom, because I haven't loaded it into Google Classroom yet. You're going to log in to Delta Math. You're just going to go straight to Delta Math. You're going to use your Google to log in with. So when it asks you to log in, you're going to click Log In with Google. Back over there, it's charging.